Hey everybody, Heston Williams here, and thanks for joining us for this episode of the W4 Show. Today, you're going to be joining Wayne and I as we go down to Wink, Texas to cut out a section of 30-inch pipe using a pneumatic beveling machine and cutter. So come on, let's go check it out. Our day started just north of the West Texas town of Wink at an oil facility. This facility processes primarily West Texas Intermediate crude, which is what's flowing through a majority of these pipes. As you're aware, most oil-field jobs always start off with a safety meeting at the beginning of the day. Here you see Wayne in the blue shirt joining the rest of the crew, a few of the welders here and a couple other hands, getting ready to go over some of the safety briefings. I'd really like it if you could hear the conversations that are going on here in the background, but the wind noise was so high that day that I'm having to do a voiceover for almost all of this video. What you see here is the guys actually mounting the machine to the pipe in preparation for the cut. They have to get everything aligned just right. You see this black arm hanging down here. That actually holds one of the two bits that are on this machine. One of the bits does the actual cutting of the pipe to separate it into two pieces. The other bit actually puts a very clean and nice bevel on the pipe. What you're looking at here in the yellow box is the air supply with one inlet on the left and two outlets on the right, an oiler and a check valve in between. Here you see a view from the top. This is the guys setting up the machine. You see the silver arm pointing up towards the guy's yellow helmet? That controls the depth of the cut. We'll see that mechanism working here in a little bit. Now that the machine is rigged up and on the pipe, we're ready to start making a cut. Whenever the machine first starts running, the bits are not engaged and it takes a few turns for them to actually get to the proper depth. Here you'll see the cutting bit start to scrape off the coating as it goes by. Now the bits have reached the depth where they're actually starting to cut into the steel. You can see that little curve start to pull up right there. So let's talk about how the depth cut is set on this machine. I mentioned that earlier, that little silver arm pointing towards the yellow helmet. Let's look at that a little more closely. Each time the arm makes a revolution, there's a little gear on top that engages with a mechanism that's on top of that silver arm. This mechanism causes the little gear to spin a fraction of a turn, and that just tightens a bolt, which sends the bit a little bit deeper. Here's a clip in slow motion so you can see how that functions. Want to see it again? Listen closely to the background sound of this. You can hear the pneumatic motor is clearly loaded up and making good cuttings. You'll see those cuttings falling onto the floor. Notice in this clip that the machine does have two different types of cutter bits in it. One is actually designed to remove the majority of the metal and separate the pipe into two distinct pieces. The other bit is what actually cuts the bevel. So in each full rotation of this machine, it both cuts and bevels the pipe with precision. So how do you know whenever you're almost all the way through the pipe? Well, in this particular case, you know whenever the machine becomes self-lubricating. That is pure, unadulterated West Texas crude there. This has not been refined. This is what it looks like straight out of the ground. Obviously, once you get the pipe completely separated into two, you're likely going to see somewhat of an offset like you see here. To me, that just looks like a glass of sweet tea. Okay. Traditional torch beveling machines have been the industry standard for decades, and for good reason. But take a look at how precisely this bevel comes out. And you couldn't have done this with a hot torch, obviously. This is true field machining in action. So now that 2 of the cuts have been made, it's time to stand around, debrief a little bit, and let the crane do its job. So now that half the day is gone and the heavy lifting is out of the way, the welders decide to show up. The good-natured among you will get that joke. Now it's time to weld the new flanges on the pipe that's actually still in place, the ends that were cut from, if you will. The new section of pipe was already prefabbed and ready to go with both of the new flanges already installed. All we had to do was wait for the welders to install the new flanges on the original pipe and then fly in the new piece here on this crane. So now that the flanges are bolted up and you have a general understanding of how the machine works, let's jump over to an interview with Wayne and Heston and talk about this day, the machine, and how it might be able to benefit you on your next job. Alright, so this is Heston here. We've got Wayne with me, and we're here to talk to you about our trip down to Wink, Texas, and about the pneumatic beveling machine that you saw in the video. It's a pretty cool machine, and Wayne's going to take it from here and kind of talk to us about that and how it might be helpful on your next job.
First off, I want to talk about the safety aspects of the process. Prior to our cutting this pipe, there had been line isolation. In other words, slip lines had been put into place, the lines had been drained, and but with that being said, we still had a high volatile type product that we were cutting into. But once we made the cut, as you see on the video, there was a foreman's plug installed. They're a great cutting tool. You can use them in any industry. There's flange facing adapters available for these two. If you have a damaged flange, you can do RTJ ring joint flanges, resurface and replace those. For any reason that you might have flange face deteriorated through time or damage from movement or something banged into it.
Okay, we can set up a machine to cut 1,000 wall pipe on a 96 inch.
That's correct.
Pipe.
Okay. That's correct. Such
what's
as vessels and vessel shells, stuff like that.
Okay, what's the smallest range there?
Probably these pneumatic cutters, you can get on down to 2 inch for your your boiler making stuff and that sort of thing.
Okay.
In that sort of thing, yeah. But one thing I have come across since this one job is another product that's available, and we're making it available to you as an end user. Is a product that has a double block and bleed. So where we had the foreman's plug in place was just one level of isolation. We had the other level of isolation with the slip lines between the blind flanges in alternate places. The double block and bleed has 2 different sealing devices within itself. Then you can also pump water into or in between on the annulus and create another seal. So you could basically have a double block and bleed with a water seal in between the 2 seal off areas.
So just for a mental picture, these 2 different seals, could a person imagine those to look like 2 pressure rated foreman's plugs with a water gap in between?
That is correct.
Okay.
with that being said, once you've done your welding process, and if you by chance wanted to hydro test your weld area after it's x-rayed, then you could move this double block and bleed system forward to the edge of the flange, and then you could pressure up to 4,500 pounds in capacity. So this just changes the whole dynamics of safety, blowout safety, during your welding processes with the double block and bleed. This just takes it to a whole different level.
So going back to the machine itself, what kind of clearance would a customer need in order to run that?
You would need between the two pipes a minimum of 12 inches clearance.
Okay. Okay. Is there any way to reduce that, just for sake of this conversation?
No.
No.
No, that would be your absolutely minimum clearance. You're also going to need to be able to have some room for personnel to get in there. You're going to have to be a lot slimmer than I am to get in 12 inches.
Okay. All right. Well, that makes sense. I mean, 12 inches is pretty tight anyway.
Yeah, it is. And these can be put in just tight proximities and ditch lines, and anytime that there's a threat of some unknown hydrocarbon product that you can't, a non-piggable line that you got a product in, chemical plants, refineries, just any kind of scenario you think that you can't do your typical flame torch beveling machine cut.
So this has applications not just in the oil field industry, but in a number of different. What about food service? Is it good in?
You could these also in food service and stainless steel applications. You see a lot of stainless in processing facilities for food products. You see stainless steel piping in butcher plants and stuff like that.
Okay. So it's a versatile machine. It can work in a number of different industries and a number of different chemical formats as well. What's a disqualifier for it? Like where is it not going to work for the customer?
Probably I would say that your clearance is going to be your handicap.
Okay. So if you had two pipes that you needed to cut and they were closer than 12 inches, that's one of the only places it won't work.
You're going to have to find some other method or come up with some idea or get some line clearance, either move up or down the line some to obtain that clearance. Also make a note that these can be either pneumatic driven or hydraulic driven.
Okay.
So there's two different power sources. That's another part that from the safety aspect of things, you don't have any electrical connections out there in a hydrocarbon atmosphere.
Any sort of volatile atmosphere.
That's true. Any kind of atmosphere that there may be an extreme flash point or problem.
And since it's a low-speed cutter bit, you have significantly reduced spark risk there too.
You don't have any spark. You're going to have a warm cutter chip, but it's going to be so cool that
so far below the flash point.
Yeah, it's going to be well below the flash point of anything. Might add one thing too, that the crew, the contractor's crew that was on site was very safety minded. They were a well-oiled machine. These guys performed well, worked well together, and there's absolutely no reason for threat or harm to anyone that I can see. They were a pleasure to work with.
Yeah, everybody was very polite, and it was just a well put together crew. It was an enjoyable situation for sure.
It was.
Thank you for joining us for this episode of the W4 Show, and we'll see you next time.
We're wrapping it up.